Hello, mister. I hope you're doing fine. Today I'm going to be talking about how to find the domain and the range of a function and how to evaluate logarithms. So the first exercise we have f of x equals to square root of 1 over x minus 2. And we see that the domain of this is the set of x such that x is greater than 2. And you will see that in this graph, you put the function on top right here and you will see the graph that the line is about to be touching number 2 and you see that it continues onward, so that's why the number is 2 and above. I mean, it's numbers that are greater than 2 because in this case, if you see we use 2, it will be 2 minus 2, it will be 1 over 0, and you know that we cannot have zeros in this type of exercises because we need to have the denominator any number but 0. And you see that the range in here it's 0 plus negative infinity. And that you can see it right here. And you see that the numbers go, and if I show you the real graph and I continue and continue, you will see that there will be no end to this axis because the graph will continue onwards all the way to infinity, positive infinitive. That's why we write the parentheses because it will continue. Here, this means the starting point, and this will mean that it has no end. Now, the second exercise is f of x equals to 6 over x plus 2. And the domain in here, it's the numbers but negative 2. So you cannot use negative 2 in this function. And as well as in this one, if you write negative 2 plus 2, it will be equal to 0. So now once again, you cannot have 0 as the denominator in this type of exercise. And you will see, here is the function. Look, it's not touching the negative 2, and as well as in this one. It's close, and as you go up and up and up, it will get closer and closer, but we'll never get to touch this line or this line. The range it's negative infinity, comma 0, and you start with a parenthesis because it's an infinity. So it also can be positive. So I forgot to write it down here, but it could also be 0, comma positive infinitive and continuing onwards because as you can see we have two lines here, negative infinitive going onwards and here positive infinitive going onwards. So now I'm going to be showing you how to evaluate logs. And here we have log of x with base 3 equals to 3. So what do we have to do here? First, we need to find the base. In this case, the base is number 3. Our exponent will be what it's after the equal sign. So here, it's our exponent, and this will be after our equal sign this time. So in here, we don't have a value for x, so we just have 3 times 3 times 3 is equal to 27. So that is the value of 27 in this case. And if you see, if you write then here log of 27 with base 3, it will be equal to 3. So you just need to check with changing this x with a 27, and you will see that your answer will be 3. In here, log of 1 over 25 with base 5 equal to x. So here we have our base, it's 5 again. Like in here, this little number, it's our base. Always, this will be our base. So here we have the base, and our exponent will be this one, equal to 1 over 25. And what gives us 1 over 25? That is 5 with the exponent negative 2. So here, since we have the same base on both sides, we just attach this, you cancel this 5 and this 5. So it will be x equals to -2. It's easy. In this case, you just need to cross both of 5's, and here you will have the remaining of x equal to -2, and that's it. Then you will only change this x with this value, and you have your answer. Pretty easy.